This video will be on section 1.1, solving equations. This section is a review. It's intended to be a review, although you might not remember everything that you've learned prior to this class. And it is one of our longer videos because it is a review of a bunch of different topics. But we'll start with solving linear equations. A linear equation is an equation with only one variable, so only one letter, and it has no exponents. No exponents meaning none written. So really the only exponents are 1. If you have exponents that are different powers, we'll talk about those in the next couple sections. And you should be very familiar with this, but we solve this by isolating the variable. And so this one we have here says solve 3 minus 6 times 3b minus 1 equals negative 8b plus 2. Now what we want to do here, just follow your order of operations. The first thing to do would be distribute the minus 6 through. Right, we cannot combine the 3 and the 6 because the 6 is attached to this. We have to distribute first when there's no exponents. If there are exponents, you might have to do things in a different order. Depends on your order of operations, and we'll see those throughout the class. Right, but distribute this minus 6 through, we got 3 minus 18b, and then minus 6 to minus 1 becomes plus 6. Make it more obvious, that is b. And then we didn't do anything to the right side, negative 8b plus 2. And now it's just up to you. Like I said, this section's a review, so you should know, what you want to do next. What I prefer to do is just combine like terms as I go. Keeps things as simple as possible. I'm going to go ahead and do that first, but if you want to do something else, be more than all right. All right, and we have a 3 plus 6, which is 9 on the left side. Those are the only like terms we have in the whole problem for now. Minus 18b equals negative 8b plus 2. And now is when I would gather the stuff. Get the b's on one side and the numbers on the other. And it's up to you however you see to do that. I'll add the 18b to the other side. And then because I want the b's on the right side, I'm going to subtract the 2 to the left side to get it away from the b's. So the 2's and the 18b's cancel. On the left side, we got 9 minus 2, which is 7. And on the right side, negative 8b plus 18b equals 10b. Right, and once we're here, you only have one step to go. We got a number times b. We want to get rid of that number by dividing by the 10. And we are left with b equals 7 over 10. And that is our final answer. Now, one thing that's going to be important throughout this class is we're not going to be fans of decimals. You want simplified fractions as your answer. Right, so get in the habit of keeping things as fractions. Do not want to use decimals and for most things in this class. Right, but that is a linear equation. Just a real quick review, this one's about as messy as we'll come across as far as a linear equation goes throughout the whole class. All right, the next section is solving quadratic equations by factoring. This is the main thing where we'll spend most of our time in this section. And there's a lot of different ways to factor. You should be familiar with all of them. If you're not, that's what this is for. That's what the review's for. But the main step is to make one side 0 when you factor in any factoring method. Right. Now, one thing I like to talk about before we actually do the problems is when do you want to think about factoring? Well, usually it's if you have different powers of your variable. So in this first one here, we have k to the second power and k to the first power. That indicates we want to factor. Right? If we had just k, it'd be like the one above. If we had just k squared, we'll do it a different way, which is later on in the section. But if you have different powers, that's when you want to think about factoring. So we have different powers here, and the first step is to always get 0 on one side. Now I prefer the highest power to have a positive number in front of it. This one already has a 1, like a 1k squared, so I'm going to subtract the 3k and 70 on both sides. So always, first step when you realize you need to factor is make one side 0. And now on the left side we've got k squared minus 3k minus 70 equals 0. Right, now that it's here, we're already in a spot where we can factor it pretty easily. As long as it can be factored, because we have a 1 out front here. So now we want to factor. We want two numbers that multiply to negative 70 add to negative 3. And those two would be negative 10 and 7. As a reminder of what you do with that, we have a k minus 10 and a k plus 7. We put a k in front of each because we have just k squared. And then we put the two numbers we figured out in the remaining parts, so the minus 10 and the plus 7. Right, now once this is factored, we say it's factored when you see the exponents are visually gone. And the reason we need it equal to 0 is once it's factored, we can set each factor to 0. Now, if this number wasn't 0 over here, you couldn't do this. If this number is like 4, you'd have to multiply this out, subtract the 4 over, and then redo it. It's very important that we have a 0 over here. But we can set each factor 0, meaning we have the k minus 10 equals 0, and the k plus 7 set equal to 0. And once you factor, usually it's pretty easy to solve the rest. For the one on the left here, we add 10 to each side, and we get k equals 10. And the one on the right here, we subtract 7 to each side, and we get k equals negative 7. And we've got two answers, 10 and negative 7. Now you'll see in the homework the directions are very clear of how to write this. You just write your two numbers separated by a comma. Pretty much anytime you have more than one answer, you'll separate them by a comma. All right, so number 2 here, similar example. You see the different powers of x. We have 3 different powers of x this time, x cubed, x squared, and just x. That indicates we want to factor. We already have it set equal to 0. But this one we don't want to start factoring the same way as the previous one because we have a common factor. We have an x in each term. So since there is a common factor, we want to factor that out first. All right, and this common factor can be numbers, it can be your variable, your letter, just depends on the problem. This one we have an x in common. We have an x inside each part, so we factor an x out. And when we take an x out of x cubed, we get x squared. When we take an x out of the 3x squared, we have 3x. And when we take the x out of 4x, we are just left with 4. And now what we have left inside here, you cannot get rid of this x, you need to leave it. Do not just get rid of it. But now what we have is something inside here that we can factor the other way, our more simple way, because the biggest power of x is 2. But more importantly, we don't have any more common factors here. There's not an x in common anymore. There's also not a number in common. So this one we want two numbers that multiply to -4 and add to +3. And that would be +4 and -1. Right, you'll see that once again, just to reiterate, I left the x out front, do not get rid of that. And that's what it factors to. Now we just follow the same steps that you should remember from before, but just in the previous problem. Now we set each factor to 0. Notice that we have 3 here. You cannot forget the thing out front. So we got the front part, we got x equals 0. We got the second part here, the x plus 4 equals 0. And the third part, the x minus 1 equals 0. Right, and then we solve each one. The one on the left is already solved. The one in the middle, we subtract 4, and we get x equals -4. And the one on the right here, we add 1 to each side, and we get x equals 1. This problem happens to have 3 answers. That's more than okay. 0, -4, and 1. All right, so one thing to look out for, you got to make sure you have 0 before you factor on one side. Look for common factors. This next one here, what to do if you have a fraction. Okay. Now, anytime you have a fraction, it doesn't matter what's in the denominator, if it's a number, if it's your letter. Whenever you're trying to solve an equation with a fraction, always multiply by the least common denominator. Get rid of the fraction. And here, the least common denominator, we only have one denominator, which is 2. So we're going to multiply everything by 2. Right, so I'm going to write it out visually and then simplify it. We multiply 2 to the 1/2 m squared minus 2 times m minus 2 times the 24 equals 2 times 0. Right, as you cannot do it just to one side because that'll be changing the equation. You have to do it to both sides. You have to do it to everything. But if we simplify this now, the 2 and the 1/2 make 1, so we just have m squared minus 2m. You don't have to keep the parentheses there. Minus 2 times 24, which is 48, equals 2 times 0, which is 0. Now once you're here, you're just back in the other spot, the previous two problems. There's no common factors here, so we can just go ahead and factor this. But if you don't do that first step, if you don't get rid of the denominator, it's much, much harder to try to factor whenever you have a fraction. All right, but we want two numbers that multiply to negative 48 and add to negative 2, and that would be negative 8 and positive 6. And now we've set each factor to 0. We got m minus 8 equals 0, and m plus 6 equals 0. Add the 8 to each side, and we get m equals 8 on the left. And on the right one, subtract 6 from each side, and we get m equals negative 6. So this one happens to have two answers. Eight and negative 6. Actually, let me write a comment, since that's what you would do on the homework. Right. So once again, this is kind of reviewing everything. A few things we've noticed. You've got to make sure you have 0 on one side, factor out common factors, and get rid of fractions by multiplying by the least common denominator. Right. The last two are usually two of the more challenging ones. Number 4 here, it says solve negative 7z cubed plus 7z equals negative 4z squared plus 4. Well, it looks a little different than all the rest, but the point being that we have different powers of z, so we're going to factor. And if we want to factor, we got to make sure one side is 0. So I'm going to just add the 4z squared and subtract the 4 to each side to make 0 on the right. And on the left, I'm going to do biggest power of z and the smallest. We got negative 7z cubed plus 4z squared plus 7z minus 4 equals 0. Right. And this one, we have nothing in common for all the factors because there's not a z here. We have no numbers in common, but it has 4 terms instead of 3. Right. And this is the thing we should have learned. This is when you factor by grouping. Right. And to factor by grouping, we look at the first two terms and factor out the common factor there. And these two terms have a z squared in common. The numbers aren't in common, but we have a z squared in common. I also don't like having the negative in front, so what I'm going to do is take out the negative as well. This is optional. You don't have to take out the negative. It's just my preference. So what I'm going to do is take out the negative z squared. In the first term here, the negative's gone. We still have 7. And then the z cubed, we took out 2 of the z's, so we still got 1 left. In the second term, since we took out a negative, this plus becomes a minus. The 4 didn't get taken out, but the z squared, all the z squared got taken out. It's minus 4. Right. And then the second part of factoring by grouping is we group the third and fourth things together, and we also factor out what's in common. This has nothing in common, right? 7 has nothing in common. 4, Z doesn't have a Z in the second part. So what we want to do is, what I like to think about when we factor by grouping is factor out a 1. And you'll see why I prefer to think about factoring out a 1. So we got a plus 1, but when you factor out a 1, it doesn't change the inside. So we still got 7Z minus 4. And if you want to check this, think about distributing back through. If we distribute the negative 7, or sorry, the negative Z squared to the 7Z, we would have negative 7Z cubed, and we would have positive 4Z squared. If we distributed the 1 through, we would get the 7Z minus 4 back. Right, so remember, the reason we factor by grouping when this kind of thing pops up is the insides are the same factor. Now we factor out the common, in this problem, 7Z minus 4. Make sure you keep your parentheses because there is that minus there. And then what's left on the inside is, well, from the first term, it's negative Z squared. From the second term, it's plus 1. That equals 0. Right. Now we have it factored, but this part here, the negative 7Z squared plus 1, is not factored completely because we have that Z squared. But you can factor the negative Z squared plus 1. That is a difference of squares. If it looks kind of funny, you can rearrange it. Meaning just make it 1 minus Z squared. Right, so I'm going to do that. Leave the 7Z minus 4 alone for a second. And then just rearrange this to 1 minus Z squared equals 0. And then remember the difference of squares. I'll write the formula here. A squared minus B squared equals A minus B times A plus B. Right, so the way it would work for us, our A squared is like 1, and our Z squared is like B squared. What that's telling us is that A equals 1, and Z equals B. Right, because A squared equals 1, well, if you just square 1, it's still 1. So we get 1 minus C times 1 plus C. Right, plugging in 1 for A and Z for B. Right. But once we were there, now you can see visually all the powers are gone, which means we can set each part to 0 and solve it. We got 7Z minus 4 equals 0, 1 minus C equals 0, and 1 plus C equals 0. Now if you want to solve the one on the left here, add the 4. You got 7Z equals 4, and then divide by the 7. Now we get Z equals 4 over 7. The one in the middle, if you add Z to each side, that's the easiest way to make Z by itself. We get 1 equals Z. And then the one over here, the one on the right, the easiest way to get z by itself is subtract 1 from each side, and we get z equals -1. Right, so this one has 3 answers as well. We got 4/7, 1, and -1. Now, if you've done factoring by grouping before, hopefully this was a reminder. Usually when you practice this a couple times, it goes a lot quicker on your own. Right. So the last one, as far as the factoring review goes, it says solve 13y plus 3 equals -12y squared. Now once again, look and see that we have different powers of y, so that means we want to factor. And if we want to factor, we want to get 0 on one side. The easiest way to do that, since I want the biggest power to be positive in front, I'm going to add the 12y squared to each side. So I got 12y squared plus 13y plus 3 equals 0. Right. Now notice here that there's nothing in common. We can't factor that 12 out. We'd like to, because if the front number is just 1, then we can do what we've been doing before. But this time though, we cannot factor out. So we have to, from here, start factoring. And there's a couple ways to do this. Since the leading term is not 1, one of the general things to do is AC method. And there's a lot of ways to branch off, but the first step is to always multiply the number that's multiplying your squared part by the number by itself. So that's what the A and C represent. And then even though we don't really reference it, B would be the number multiplying just the first power part. Right, so we start by multiplying A times C. Here we have 12 times 3, which is 36. And now what you want to do, you kind of think about it the same way. We want two numbers that multiply to this 36 and add to the middle part, which is 13. Right, so a little bit different than before because our A is 1 in the previous problem. Right, so two numbers that multiply to 36 and add to 13 would be 4 and 9. Right, now what you do from here, there's so many different ways. You can look up the AC method, the box method. Some people do guess and check. But really, if you don't do this first part here, the bigger the A is, the more chances there are to be wrong if you do just guess and check. So it's very important to figure this part out first. But we're going to have two factors. Right? And what we want to do is think about, if we were to FOIL them out, how would we get a 4y and a 9y? Well, the first thing I would think of is 12 is 4 times 3. So let's start with 4y and 3y. Right, the reason I want to do that is 4 matches the 4 here. 3, it doesn't match 9, but 3 times 3 is 9. See, I wouldn't want to do 6 and 2 because there's no way to make 9 from 6 or 2. Also no way to make 4 from 6. Right, everything's positive here, so we're going to have pluses. And then luckily for us, 3 here, there's only really one possibility that would work. But think about how to make 4y from 4y, we'd want to multiply it by 1. Remember when we FOIL, we would multiply the 4y times this over here. And then to make 9y, we would multiply the 3y by the 3. And this would work out. If you FOIL this out, you'll get this back. And everything else works. All right, but once again, if you don't figure this part out, then you could be stuck for a while, because you might try 12y and 1y, 6y and 2y, 4y and 3y, and then switching the 3 and the 1 and so on. So think about it the way I thought about it. Right, but if you learn another way, do your other way. That's perfectly fine. Right, but now that that's factored, then we can set each factor to 0. From here, it's all the same as the other ones. We got 4y plus 3 equals 0, and 3y plus 1 equals 0. Solve the one on the left, we subtract the 3 from each side. We got 4y equals negative 3, and then divide by 4. We get y equals negative 3/4. The one on the right, we subtract the 1 from each side. We got 3y equals negative 1, and then divide each side by the 3, and we get y equals negative 1/3. Right, so this one happens to have two answers, negative 3/4 and negative 1/3. Once again, leave everything as fractions, even if the decimals are simple. Like this would be negative 0.75 and it would be done, but it's just best to leave everything as a fraction. All right, so there are two more little parts to this section. One is solving equations using radicals. Right, so when faced with an equation that factors or simplifies down to x to a power equals the number, the easiest thing to do is use the appropriate radical to get down to x. So if the power is even, you must put a plus or minus on the number sign, but if the power is odd, you do not have to put anything extra, as we will see below. And the one you're probably most familiar with is when you're just left with like an x squared. The way you get rid of the squared part is do the square root. All right, so this first one here, it says solve 3y squared plus 24 equals 0. Right. So comparing this to the problems we were doing before, the reason we wouldn't want to try to factor this is there's only a y squared. There's not different powers of y. What we want to do instead is isolate or get the y squared by itself. Just like if we had just y here, we would get y by itself. So we want to get y squared by itself first. And we subtract the 24 to each side. We got 3y squared equals negative 24. And then we want to get the y squared by itself. We divide each side by the 3. You must divide by the 3 before you worry about getting rid of that squared, because the 3's in front has to be gone first. We got y squared equals negative 8. Right? Now, once you have the y squared by itself, now is what we outlined before. You scroll up just so you can read it, but we want to do the appropriate radical. And the appropriate radical here would be the square root. All right, so let's go ahead and write that. What I'll do is I'll rewrite the problem so it's more clear that we are not skipping steps. Take the square root. Make sure you put that negative in the square root. Whatever's on this side over here on the right has to go inside the square root. And then the one extra thing is, since the square that's an even power, we must put a plus or minus. Now, something should be going off in your head about what's happening on the right side, because we have a negative inside the square root. Right, on the left side, we're just left with y because the square root and squared cancel out. But we cannot do the square root of a negative number and get a real answer. You might be familiar with imaginary numbers, and that's okay, but we're not dealing with them yet. That means there's actually no solutions to this problem. Because we solved for y, we got only imaginary answers. This plus or minus doesn't even matter for this problem because that number is not real. You want to check it, or you just forgot about it, you can check on the calculator. You can do the square root of -8, and it'll tell you it's a not real answer. Right, so one thing about the calculator that I really like it for is just checking. You can type in your answers, check your answer by plugging it into the original, see if it works, and your calculator will tell you if it's the right answer or not. You have to do the work to get there, but at the end, it can tell you a lot. All right, so number two, very similar idea, but it doesn't look similar at the beginning. We'll see why it turns into a similar problem. It says solve 4z to the 7th power equals 16z to the 5th. Now this one, it should be going off in your head that you have different powers of z, so you need to factor. Right, if we need to factor, you need to make 0 on one side. One thing that you should have learned in math before is that you never divide by a variable. Right, so to get 0 on one side, you don't want to cancel out any z's here, even though it might be enticing. You have to subtract. Right, so I want to subtract the 16z to the 5th on each side to make the biggest power of z, stay positive like I enjoy. We got 4z to the 7th minus 16z to the 5th equals 0. Right, now at this stage, this isn't something that looks like you would want to factor in the normal way, but what you should always do is check for common factors and factor out common factors. Right, so here we have a 4 in common, which we can take out, and we also have a z to the 5th in common. We can take out the smallest power of z and the smallest factor of a number. Right, and the first term, what we're left with is just z squared. We took out the 4, we took out 5 of the 7 z's. In the second term, we are left with taking a 4 out of 16 gives us a 4, and z to the 5th is all taken out. Right, so here, this one is similar to a previous one, but I'm going to do it a different way, and then just, you can choose which way you prefer. So before, when we solved this factoring by grouping, we said that we should factor it because there's a z squared there. And that is optional. You don't actually have to factor it. You can do something else. So at this point, once you factored even a little bit, you can set each factor to 0. So we have 4z to the 5th equals 0. Make sure you do the whole thing. And then z squared minus 4 equals 0. Now the one on the left, divide by the 4 on each side. And we get z to the 5th equals 0. 0 divided by anything is 0. And should have left myself some more room. But if you have anything raised to a power equals 0, that means that thing is 0. All right, so since we have z to the 5th equals 0, that means z equals 0. And z to any power, positive power, I should say, means z equals 0. And of course, that goes for any letter. Z is just a variable. Now the one on the right, instead of factoring this, we can do it like the previous one. We can get the z squared by itself by adding 4 to each side. So we got z squared equals 4. Now we do the square root of each side because we want to get rid of that squared. So we got the square root of z squared equals plus or minus the square root of 4. We're going to the plus or minus again because the power is even. And the squared and the square root cancel out. So we got just z. And we got our plus or minus. The square root of 4 is 2. So for this problem, we actually have 3 answers. We got 0, and we got 2, and negative 2. So this is saying positive 2 and negative 2 are both answers. All right. And once again, the amount of answers really is not related to the problem. You can't just look and tell. It could be any number. It could also be 0, as we saw in the previous one. One thing I should mention, the homework does tell you, but I'll just write it now. If you have no solutions, you write D and E in the homework. But it does tell you if there are no solutions, write D and E. Right, so the last example here, using this property, is to solve something like 6a plus 5 squared minus 38 equals 0. Now, what you want to do here, you don't actually want to try to square this out, multiply it out, because you only have a in one spot. What the smart thing is to do, which is what we'll do, is if we add the 38 to each side, then we can do the square root, because this will be by itself, and it will make the power go away. It'll make it easier to solve for a. All right, so let's go ahead and do exactly that. I'm going to add the 38 to each side. We got 6a plus 5 squared equals 38. And now you can do the square root of each side because the entire thing is squared. So we do the square root of each side. We do not forget our plus or minus. The squared and the square root knock each other out. So we're on the left side, we just have the inside. You don't have to write the parentheses anymore because the exponent's gone. 6a plus 5 equals plus or minus the square root of 38. Right, and now you want to solve for a. But this radical doesn't simplify. If it was 36, that'd be nice, but it's not. So now we're going to get a by itself. And don't worry about the plus or minus, just keep writing it where it is. We will deal with that at the end. So just imagine if this was a number, how would you get a by itself? We would subtract 5 from each side. So 6a, what I recommend when there's a plus or minus problem is put everything in front of it. So we got minus 5 in front, plus or minus the square root of 38. And then we have 6a equals this. Dividing by 6 will give us a by itself. Right, and this gives us two answers. As messy as this is, they are simplified. The way you want to read your answers, just write 1 with the plus, the negative 5 plus the square root of 38 over 6, and 1 with the minus, negative 5 minus the square root of 38 over 6. All right, what you do want to make sure you are careful about with this problem, when you get the answers, the minus is on the 5, it's not out front. So when you make your fraction, make sure the minus is on top of the fraction, not in front of the fraction. Right, so the last thing in this section is solving literal equations. A literal equation is an equation with many variables, so at least 2, and you must solve for 1. When given one of these, you will not get a number as an answer, but an equation. Right, there's not many in the homework, but they are important as we work through the class, and I intentionally chose the harder ones to show you how to deal with them. The first one here says solve y equals 6x plus 7 divided by 5x plus 6 for x. Right. Now, one thing I said in a problem before is always get rid of fractions when you're solving for something. So we want to multiply by the LCD to get rid of fractions. And the LCD, the least common denominator here, we only have one denominator, so it's 5x plus 6. All right, so what I'm going to do is take my equation and multiply everything by that 5x plus 6. All right, so I'm going to do it on the left. So I got 5x plus 6 times y. I'm going to do it on the right. So we got 6x plus 7 over 5x plus 6, and then multiply that by 5x plus 6. All right, we only have two terms. When you have a fraction you multiply through, you only do it once. And the 5x plus 6's cancel out on the left or the right side. So for now we have 5x plus 6 times y equals 6x plus 7. So once you do that, then we want to get x by itself. But when you get x by itself, it can only be in the problem once. And here we have x twice. We have it on the left side and the right side. So what you want to do is distribute the y through here, because we cannot move the 5x over with the 6x with this multiplication of y here. So we have to do this first. So we got 5x times y plus 6y, multiply the y to both, equals 6x plus 7. And now you want to gather the x terms on one side, the things with x on one side, and the things without x on the other. Right, and it's up to you which side you want to do that. I'll bring the axis to the left. So I'm going to subtract the 6y to make it go to the other side, and then subtract the 6x to bring it over to the left. Right. Now it doesn't matter what else is in the term. If x is in it, bring it to one side. If x is not in it, bring it to the other. Right. So on the left side here, now we have 5xy minus 6x. And on the right side, we've got negative 6y plus 7. Right. This is the only way you're going to get down to just 1x. Is bring them all on one side and then factor the x out. Even if you have something else in common, only factor the x out. Right, when we take the x out on the left side, we get 5y minus 6. And on the right side, we didn't do anything because there's no x's there. And that is by design. And now you're actually only one step away. We have x times this thing equals this. If you want to get the x by itself, divide by the 5y minus 6. And that way we will be left with just x. And x equals negative 6y plus 7 over 5y minus 6. Now when you type your answers in for this, you need to write the whole equation because it's going to expect x equals. Don't just write the right side. All right, now one thing I want to mention real quickly, just to reiterate, when we're at this step here, after we got rid of fractions, why did I not just subtract the 7 and divide by the 6? Well, it's because there's an x over here. So if you want to solve for a variable, you can only have that variable on one side. You cannot also have it on the other side. So that's why you got to go through all these steps. All right, number 2 is a similar idea. This one happens to have 3 variables, but that's not really more of an issue, as you'll see. So this one says solve 5 divided by p equals 6 divided by r plus 5 divided by u for u. Now we want to start with the same thing. It doesn't matter what the first thing says or what it says to solve for. I could say solve for p, it could say solve for u, it could say solve for r. The first thing I'm going to do is multiply by the least common denominator to get rid of fractions. Whenever you're solving an equation, I can't reiterate it enough. If you have fractions, do everything you can to get rid of them. Here our least common denominator is p times r times u. Right, since they have nothing in common, we have to multiply by all of them. Right, so we're going to do exactly what we've done with the other problems. We're going to multiply everything by our least common denominator, which is p times r times u. And that's to the 5 over p over here. Then we multiply p times r times u to the 6 over r. And then we multiply p times r times u to the 5 over u. Now, doing that should always make all the fractions cancel out. So on the left here, the p on the bottom cancels with the p on the top. In the second part here, the r on the bottom cancels with the r on the top. And in the third one over here, the u on the bottom cancels with the u on the top. And what we are left with, we have in this left term over here, we have r times u times 5. I like to put the numbers in front, so I'm going to put 5ru. In the term right here, we have 6 times p times u. And in the last term, we have 5 times p times r. Right, so we got rid of the fractions. Now what did we do last time? We wanted to get all the x's on one side because we were solving for x. Since we're solving for u here, get the terms with u on one side, terms without on the other. And this one has 2 terms with u. The 5RU and the 6PU have u, and the 5PR does not have u in it, so we want to subtract the 6PU to get it on the side by itself, with u. So that's the quickest way to make sure you got the u's on one side and the not u's on the other. Right. So we got 5RU minus 6PU on the left, and on the right we have 5PR. And once again, just think about what we did last time. We got the x's on one side so we could factor it out. This time we got the u's on one side for the same reason. Factor it out. So we take the u out, and we got 5r minus 6p on the left. There's no u on the right, once again by design. We have equals 5pr. And then the final step, just like last time, after we factor out, we divide by that 5r minus 6p. So we divide each side by the 5r minus 6p. And this one certainly is not a nice looking answer. The other one before wasn't either. That's just the way it is. So we got u equals 5pr over 5r minus 6p. And just like last time, write the equation. Don't just write the right side. Be ashamed to do all that work and then not get your credit. But that is solving literal equations, and that is really our review. We hit all the main topics. We will solve equations like all of these throughout the class, mostly the factoring and the square root, but make sure you know how to do them all.